Recall that each row of our data matrix corresponds to one of the two types of users. Even if we observe only very few ratings per row, they should be similar for users of the same type. To see this, let's take a closer look at the similarity between rows. It should reflect the similarity between users' preferences. For each pair of rows, we can measure their similarity by looking at their inner product. This notion comes from linear algebra, and it's a single number that can be computed as follows. First, stack the rows on top of each other. Here, we only show rows of size 10 rather than 17,000 for the sake of demonstration. Then, we multiply each entry of the top row by the corresponding entry of the bottom row and add these products. Of course, question mark times 4 is not well defined, so we simply replace the question marks by the average rating, 3. When we multiply each corresponding pair of numbers, the one on the top with the one on the bottom, we get this new sequence of 10 numbers. Finally, we add all these numbers to get 101. We say that the inner product between the top row and the bottom row is 101. What does this number mean? Well, it's a measure of proximity between the rows, so the larger the inner product, the more similar the rows. Back to our Netflix example, a large inner product between two rows means that the corresponding users have similar preferences. In the toy example that we've just constructed, where there are two types of users, Frank and me, and two types of movies, chick flicks and action movies, let's see what these inner products look like. We could, of course, write a long list of inner products, but there are a lot of them. Actually, this number is the number of distinct pair of rows, right? For each pair of distinct rows, we can compute a new inner product between them. For n rows, this number of pairs is given by the formula n times n minus 1 divided by 2. So for n equals 500,000 rows, as in the Netflix price dataset, that number would be around 125 billion, which is about the number of stars in our galaxy. So a list of all inner products would be pretty useless, but we can get a good summary of this list using a histogram. In our toy example, this is what a histogram looks like. We can clearly see that there are two different modes. This suggests that there are two types of values for these inner products, large and small. When two rows come from the same user type, we get a large value. When they come from two different user types, we get a small value for this inner product. This suggests the following picture. The blue dots correspond to users of the first type, one that are into chick flicks like Frank. And the red dots corresponds to users that are into action movies, like me. Of course, this two-dimensional picture is only a cartoon. In reality, this picture takes place in a 17,000 dimensional space. 17,000 is the length of each row in the Netflix dataset. Moreover, the clusters may overlap, like this. Now that we have made this observation, we can devise a personalized recommendation system. The idea is simple and consists of using a well-known machine learning technique called nearest neighbors. Since users are clustered into two groups, even if they are not exactly the same, the ones corresponding to similar rows are likely to be users of the same type. Assume that Frank is here. Then all the users that are in a certain radius are of the same type as Frank, chick flick fans, and their ratings may be averaged without risking to include the ratings of action movie fans. And that's personalization. Here, all recommendations will be personalized to each user type, either chick flick fan or action movie fan. In other words, all the rows that have a large inner product with Frank's are likely to have preferences similar to Frank's. Once we have identified the set of users that are similar to Frank, we can apply the techniques that we saw in the previous video, because for these users, there is only one single true rating for all movies. This rating can be used to output a single ranking. It is believed that the Netflix dataset has at most 15 different types of users. In a way, this is not such a large number, but it's certainly more than 2. We will see a straightforward extension to more than 2 groups as part of the next video. This video was about personalizing recommendations. We saw an example where the data contains at most 2 types of users. In this toy example, we saw how to identify users that are likely to belong to the same group by looking at inner products. Inner products between the rows of the data matrix are a measure of proximity between users. Finally, we grouped users according to their proximity. This is the nearest neighbor technique, and we computed an average rating within each homogeneous group. Effectively, we have personalized our recommendation to each group.